Okay, in day 2, we can use synthetic division to evaluate polynomials. This is called synthetic substitution. This process is exactly as the process of synthetic division, but the final answer is interpreted differently. So the final answer is actually that evaluation. So it's called the remainder theorem. If we have a polynomial function and is divided by x minus a, then the remainder r is that function evaluated at a. And you're wondering, what the world did I just say? So I'm going to use synthetic division. So my x equals 4 is my a. X to the third, x squared, x constant. Bring the first one down, multiply, add, multiply, add, multiply, add. So the function evaluated at 4 equals 7. The next one we have negative 1/2, x to the fourth, x to the third, no x squares, 3, 5. Bring straight down, multiply, add, multiply, add, multiply, add, multiply, and add 5 minus 3/2, which is 5 minus 1/2, is 3/2, or 7/2. So p at negative 1/2 equals 7/2. So you go ahead and try these, or you can continue watching the video and watch as I do them. Oh, and I did this one wrong. I'm sorry. That's actually an x to the third and x squared, so there's no column here. Apologize for that. It's an x squared, x constant. What are the differences between synthetic division and synthetic substitution? Synthetic division, you have a remainder. Synthetic substitution is an evaluation. It's actually the value. Okay, so now we get into some applications. We have a machine that produces very high voltages. One machine has a current that can be modeled by this function, t plus 2, where t represents time in seconds. And the other one, the power of the system can be modeled by this function, 0.5 t to the third plus 6t squared plus 10t. Write an expression that represents the voltage of the system. And you can see voltage equals P divided by I. So my I is t plus 2, and you can decide how you want to divide this. I think that's going to actually be in the next part. So here's our expression to represent V. Sorry about that. Just need the expression. And then actually do the division. So you can do either way, long division. Or synthetic division where your A is -2. Okay, so if I do this, subtract, bring down, take a 0.5 t squared plus 5. Over here you bring this down, you multiply, add, multiply, same answer. So it's really whichever method you like. So you have one to try on your own here. You're basically dividing y squared minus 14y plus 45 by y minus 9. I'm going to choose synthetic division. And which of the variables in the problem represent? Well, t is time. Vt is voltage. And I of t is current. That was in our first one. In this one, right above us, the variable is a length. Can you use synthetic division divide polynomial by x squared plus 3? And I'm going to say no. This isn't in the correct form. It needs to be x minus a, not a squared. Explain how to quickly find P6 for the function without using calculator. Well, you can use our theorem, synthetic substitution. Where you do 6 2, negative 11, negative 5, 2, add, 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 so P of 6 equals 8. And this ends day 2.